Hello friends, now we are going to determine the chemical oxygen demand. We know that our wastewater sample may contain organic and inorganic waste. All the waste is not completely oxidized by the bacteria. For the oxidation of such waste, we need the strong oxidizing agent. This strong oxidizing agent will oxidize that waste. During that oxidation of waste, how much amount of oxygen is utilized, that is the chemical oxygen demand of that wastewater sample. The chemical oxygen demand is defined as it is the amount of oxygen required by the organic and inorganic matter present in the 1000 ml of wastewater sample using a strong chemical oxidizing agent like acidified potassium dichromate. Here, acidified potassium dichromate is going to oxidize the organic and inorganic waste present in the water. During that oxidation, how much amount of oxygen is utilized, that is the chemical oxygen demand of the wastewater sample. The determination of COD is done by the following principle. Here we are going to take the round bottom flask. In that round bottom flask we are going to take the wastewater sample. That wastewater sample is refluxed along with a known concentration with a known volume of potassium dichromate with a dilute H2SO4. Along with that potassium dichromate, we are going to add the 1 gram of mercuric sulfate, which will avoid the interference of Cl minus ion during the reaction. And then we are going to add the 1 gram of silver sulfate, which is act as a catalyst for this reaction. The entire reaction mixture is refluxed for about 2 hours. During that period, the certain amount of potassium dichromate is utilized in the oxidation of waste. After the 2 hours, we are going to determine the unreacted potassium dichromate present in the flask by using standard FAS solution and Ferrine indicator. Here, for the determination of COD, we are going to do the two titration. One is sample titration, other one is blank titration. In the sample titration, we are going to take the round bottom flask. In the round bottom flask, we are going to take a known volume of wastewater sample. Then we are going to add the potassium dichromate of known concentration and known volume along with dilute H2SO4. Then we are going to add the 1 gram of mercuric sulfate and 1 gram of silver sulfate. The entire reaction mixture is refluxed for about 2 hours. Then the refluxed mixture is cooled down. During this reflux time, certain amount of potassium dichromate is utilized for the oxidation of waste. Then the cooled reaction mixture is transferred into clean conical flask for the determination of unreacted potassium dichromate. To that reaction mixture containing conical flask, we are going to add the 5 drops of Ferrine indicator. This will become blue. Then where this blue color solution is titrated against standard FAS solution till the color changes from reddish blue to reddish brown. Final color changes reddish blue to reddish brown. Then the amount of FAS utilized in the titration is noted down. Then we are going for the blank titration. During the blank titration, same procedure is followed as in sample titration. But one thing is different. Here, instead of taking the wastewater sample, here in the blank titration, we are going to take the same amount of distilled water in the place of wastewater sample. Here, whatever the potassium dichromate present in this blank titration will remain as it is, because distilled water is completely free from the impurities. So that whatever the potassium dichromate is added here, it will remain as it is. So that amount of FAS utilized in the blank titration is more and the amount of FAS utilized in the sample titration is less. Then we are going for the calculation. The volume of sample taken in the sample titration, that is VML. Then volume of FAS in the sample titration, that is AML. Then volume of FAS used in the blank titration is, that is BML. Then the normality of FAS taken for this titration is N. The amount of potassium dichromate consumed in order to satisfy the COD in terms of FAS, that is B minus A. Here we are going to express the amount of potassium dichromate utilized in the reaction in terms of FAS by taking the difference in FAS reading from the sample titration to blank titration. Then the normality of COD sample is given by N1 into V is equal to N into B minus A, where N1 is normality of COD sample, V is volume of water sample taken, and N is normality of FAS. B minus A is the amount of potassium dichromate is utilized in order to satisfy the COD in terms of FAS. Therefore, normality of COD is equal to N1 is equal to N into B minus A divided by V. Therefore, COD of the sample is equal to N into B minus A divided by V into 8 into 1000 milligram per liter, where 8 is the equivalent weight of oxygen.